Okay, 12.2 notes. So today we're still doing things that are going to be useful for us as stepping stones. So some of it is going to pull some stuff from yesterday, and then we're adding some other things. So a lot of the stuff we have talked about in the past, but again, we want to really make sure that we have all the pieces that we need to do the harder stuff later. So the first thing that we're going to review, because we've done this before, is difference of squares. So we're going to be factoring here. And as you can see, you only have two pieces. So it's normally ax squared plus bx plus c, but you only have a and c here. So if it helps you and makes you feel better, you're more than welcome to write it as x squared plus 0x minus 4. But in cases later, if you can start getting better at avoiding doing it like that and just knowing that it's a difference of squares, that's great. But there will be other situations that it might be confusing, and we can talk about that more later. But putting that 0x in there can help you out if you need it. So now we're thinking about how does this factor, so we're thinking about what multiplies to be -4 and adds to be 0. So since it's a difference of squares, it's always going to be the same number because they cancel out and get that 0 part. So we're thinking of 2 times 2 is 4. Yes, there are other options for 4, 4 and 1, but again, we want things to cancel. So we are going to do x2, x2, and then if we want them to cancel out, we need them to be opposite of each other, so 1 plus and 1 minus. So when we actually check it, 2 minus 2 is 0, and then 2 times -2 is -4. So we can live without the 0x in the middle by saying, okay, same situation. What gets us the 9 when it's the same number to cancel out the middle because there's nothing in the middle? So 3 times 3 is 9. So we're going to do x3, x3, and then to cancel them out, we need one of each, a plus and a minus. So as you can see, that would get us 0, and if we were to actually write it with the 0x, you can see that piece, but that's what's happening. So then let's keep going. X squared minus 1, so we're going to do x, x, and then the only option is 1 and 1, and then 1 is plus and 1 is minus. So now it's your turn to try the last 3 there. So I'm just going to write the answers, and you're going to check them. And just a heads up, if you're struggling, like you don't know what times itself equals 49, you can undo by doing the square root of 49. All right, so hopefully that part felt easy to you. If not, there will be some more room for practice in the future. Now looking at the next section, it says greatest common factor, so GCF. So we've done that, but now we're looking at some other situations. So here it has 3x plus 3. So we're trying to figure out what these have in common and the highest thing possible. So they both have a 3. You can't get any higher than that in terms of numbers, and they do not have any x's in common. So I can take a 3 out of both of them. So when I do that, that 3 goes on the outside, and then I think about what I have left here. So 3 divided by 3 is 1, and then there's an x. You can write it as 1x or just x, and then plus 3 divided by 3 is just 1. So we do need that 1 to kind of be that placeholder there. So if I were to distribute this 3, it should become that top equation. I'm sorry, that top expression. The next one here, the biggest thing that they have in common is 2. They don't go any higher than that, and we don't have any x's that we can put there. So I'm going to say 2 and then parentheses. 8 divided by 2 is 4. And then negative 2x divided by 2 is negative x. You could write it as negative 1x if you wanted. Number 9, This one is a little bit more tricky because they have a number and a letter. So the number is 3. 3 and 6 are both divisible by 3. And then they both have at least an x. So we're going to take that out. So we have 3x and then parentheses. So 3 divided by 3 is 1. And then x squared, take out an x, is just x. So 1x, and I'm just going to write it as x. But if you want to write it as 1x, that's fine. And then over here we have minus, and then 6 divided by 3 is 2, and then x divided by x, you don't have any x's left there. So now on the next one, the biggest number that they have in common is 6, and there is no letter they have in common. So we're going to take out 6, and then we've got x squared minus 1. Why don't you try 11 on your own, and then we will do 12 together. All right, so now number 12, looking at this, they don't have a number in common, but they do have a letter. Now, when we're thinking about this, we've only dealt with just x's, but looking here, we have more than just x. So the biggest number they have in common, that's the thing. They both have 2 x's. So it's like I've got 3 here, and then I've got minus 4, and then 2 here. So the biggest amount is they have 1, 2 together. So 2 is the biggest they can go. So we're going to divide both of those by x squared. So x squared, x squared. So I've got x squared on the outside, and then I am left with, if I had 3 and I took 2 of them out, I am left with 1 of them. So you can just write x. And then minus, I have 4. And then if I had 2 and I took 2 out, I have none left. So it's just that 4. All right, when you're ready, turn to the back. All right, so factoring trinomials, we're just doing what we did yesterday, doing some more practice of that. So remember, we're figuring out what multiplies to be the last number, that's our first step, and then what adds to be our middle number, that's our second step. So we're gonna have all these like this, and none of them have to divide out a GCF, so we're just going to get them all set up now. And we know that all of them are going to have those x's. And we can do where we are writing the list, so like all the things that multiply to be 1, all the things that multiply to be 9, or you can try to avoid that by using stuff in your head or on your calculator or your tables if you want, but I'm going to try to do it without. So we're thinking about the only things that multiply to be 1 are 1 and 1, so I'm locked into that decision. And then if I want it to be positive 2, I need positive 1 plus positive 1 to get us that. And then we could technically write this, since they are the same, as x plus 1 squared. On the next one, we've got 9 times 1 and 3 times 3. I said I wouldn't do this, and then I did. We want it to be 6, so 9 and 1 versus 3 and 3. The 3 and 3 can create 6, but 9 and 1 cannot. So 3 and 3. And if we want it to be positive 6, we're going to do positive 3 and positive 3. And we can also change this by writing it as x plus 3 squared. And when I say change this, I mean visually. It doesn't actually change the expression. It's still the same situation. So then number 15, the two numbers that multiply to be 21 and still can get us 10. So you can kind of like, I can talk through like what I would be thinking in my brain of like, okay, well 20 and 1 is like not realistic because that's not even close to 10. So I need to kind of go in there some more. Like 21, what about 7? 7 times what is 21? 7 times 3. 7 and 3 also add to 10, so that's good. So 7, 3. And then we're thinking, okay, if this is positive 10, they both have to be positive to add them together to make 10. All right, number 16. So 77 is quite a large number, but we know that since those digits are the same, hopefully, that 11 is going to be the one that we're going to be using. So 11 times 7 is 77. So 11 and 7. Now let's check. 11 and 7, 11 minus 7 is 4, so that helps. So now we want it to be positive 4. So 11 minus 7, so that means 11 has to be positive. All right, number 17, what multiplies to be 12 adds to be 7, and 18, what multiplies to be 18 adds to be 9. You do those two on your own and then check your answers. Okay, now let's go to our last set of items. So now we're going to be putting things together just like we did yesterday. So greatest common factor and factoring. I see that says and trinomial. I meant a trinomial, so sorry about that. But so we're going to start with, can we take anything out? That's always the goal if we've got a number in front. So looking here, I'm going to try to divide everything by the biggest number possible. So 2 is true, but anything higher than that, no, because that can't go above 2. So 2, and then do they have any x's? No. So I'm going to leave the 2 on the outside, and I have x squared plus 12 divided by 2 is 6x plus 10 divided by 2 is 5. So now I'm just looking at this and factoring that. I'm going to leave that there and pop it into my answer later. So I'm figuring out what multiplies to be 5 and adds to be 6. There are only 2 numbers that multiply to be 5, so that's 5 and 1. And then to make it positive 6, we need positive 5 and positive 1. So this is pulled apart as much as we can. Number 20, we're going to divide everything by this biggest item possible, including numbers and letters. So 14 is the highest number divisible. So we're going to put that 14 on the outside. Now we have left x squared minus 2x plus 1. 14 divided by 14 is 1. 28 divided by 14 is 2. 14 divided by 14 is 1. And the 1 we had to put at the end, but not in the beginning, because there needs to be that like placeholder at the end. Oop, I'm not done, no box there. We're figuring out what multiplies to be 1 and adds to be 2. So we got 14 and then x, and the only options of multiplying to be 1 are 1 and 1. And then if we want negative 2, we're going to do minus, minus, minus. So you could also write it as 14x minus 1 squared. Number 21, the biggest thing they have in common is 5. I always try that first piece out in front. So if I put 5, and now I have x squared minus x minus 7. Nope, sorry, 6. Whew. So when you did that minus x in the middle, I do put like a 1 in there later when I'm doing multiply add, because that's useful to remind myself that that has to be a 1. So I'm thinking, okay, 6 is 6 and 1 and 3 and 3. But if I want it to, nope, that's also wrong. 6 and 1, 3 and 2. And if I want it to become a 1, the 6 and 1 is not going to help. So let's try 3 and 2. So x3, x2. So I'm going to want it to be a negative 1, so it's going to be minus 3 plus 2. I am running out of battery, so we might have to rush this a little bit. All 3 of these have a 3 in common, so we're dividing everything by 3. So now I have x squared minus 3x minus 4. Then we have to figure out what multiplies to be 4 and adds to be 3. So we've got 4 and 1 or 2 and 2. Well, 4 and 1 would get us 3, so 4 and 1. And if I want it to be negative 3, I have to take away the 4 and add the 1. 23 is actually going to be an x. In this case, it's only one x that they all have in common, so I take that x out, and now I'm left with, if I have x cubed, so if I have 3 and I take 1 out, I have x squared left, minus 11, and then took out 1x, so I have 1x left, and then plus 24, took out an x, don't have any x's left. Now I'm figuring out what multiplies to be 24, adds to be 11. So I'm thinking, okay, 24 and 1's out, 2 and 12 is out, keep going. What about 3 and 8? So 3 and 8. 3 plus 8 is 11. So if I want it to be negative 11, I need them both to be negative to get to that 11. And then the next one has a combo deal, of course. So we're going to divide by the highest number, which is 2, but we're also dividing by the highest letter, like number of x's, which is just one of them. So 2x, and then I'm left with x squared minus 15x plus 50. So we'll talk through that real quick. 2 divided by 2 is 1. 3, take out one of them, you have 2 left. 30 divided by 2 is 15. 2, you take out 1, you have 1 left. And then 100 divided by 2 is 50. 1, you take out 1, you have none left. So we're figuring out what multiplies to be 50, adds to be 15. So to get 50 and 15, we're going to do 5 and 10. 5 times 10 is 50, and then 5 plus 10 is 15. But we want negative 15, so I'm going to do minus, minus. All right, you are done. You don't have any homework. Have a good weekend.